Hi, this is Alan Luker. I'm one of the steak technology specialists for the Bennion, Utah steak. And this is about some technical documentation of how we use the cameras in our steak. We have an ASL ward, which makes things kind of interesting. So here we go. So the cameras in our steak center typically we've been using handheld remotes. In 2019, the sound system was upgraded, and Sony, we got a new Sony camera and the center camera in the chapel, but they also left behind a Sony controller, an IP10, RM IP10 is what it is, and um, was not on the design for them to actually implement, but it was actually spec, so that was part of the bid documents. So we took in and successfully implemented that camera after it was about a year or so after. Kept on looking at it and thought we ought to put this thing together. But nice thing about it is it gives us more granular control, more immediate response. Works really good. Also on the plan, that in those 2019 design plans was the RS-232 VISCA port of the Lumens. We have a corner camera also, and I'll talk about why they do that a little bit. But we were able to. What I think is interesting is I always thought that RS-232 just had a length of 50 feet. You didn't want to do any more than that, because RS-232 is what we call an unbalanced circuit, and it has a transmit and receive it. They share the same ground, or return on it. So it makes it unbalanced. But evidently, when you run this through Cat 5 or Cat 6 cable, because of that twist in there, to eliminate which has always been in there, to eliminate the capacitance it builds up, you can extend RS-232, at least at 9600 baud, for up like 300 to 400 feet. So this is what they had here. Uh, we took a laptop in, tested it, and found some software we could control it with, and found that it actually works. So now the challenge was, how do we extend the remote control function to what we call the ASL PC we have on the rostrum in the chapel, and that's a PC that does a lot of things, that produces um, the results that the deaf ward needs. Okay, so in this presentation, I'm going to go through the implementation. This is not really a how-to document, so but just a how-to, an operations document. This is more of a technical document for those who might be um, interested in replicating or need to support this. Okay, so I've taken off the um, the design documents two pieces. I've just kind of overlaid it together. This was on one sheet here. You can see that I haven't quite lined up here. With ET 101. This was the corner camera, and then this snippet I took here is on ET 103, which is the sheet for the design and that the installers use to install the system. Is the ASL camera. So as I say there, church engineering perspective, the center camera is the ASL camera because it was the first thing that was ever installed on a building. Um, so then the corner camera is something you find in a standard. If they're upgrade a steak center, you'll find it there installing a corner camera now in most of the buildings. So that's kind of a standard feature. So and generally that's how we use it. The ward that I'm in, which is 19th, and the Spanish wards, when we're using Zoom for a webinar, will use that corner camera. The center camera is just a projector. It's used every Sunday by the Salt Lake Valley Deaf Ward, second ward. The stake will use both cameras uh, in addition to do the state conference, and we'll show you a little bit about that in this presentation here. And we also use both cameras for special uh, meetings or events that may have, like we've done some for the Relief Society, so on, that kind of thing. what you see here on the screen, President Stewart designed, had this scheme in his head that he wanted to do. And one of the things that I don't really cover here, but the third piece of this is his pad. It's a Samsung pad here. It could be an iPad or whatever. That we use OBS, which is an open standard video software, to put these all together, and that's what the ASL PC does. And there's for the ASL award, they like to piece together the interpreter, and when they do hymns, is what they use it for an award. But here he's combining them together here. So here we have the ASL translator. It's being focused on the center camera right here. And then we have the speaker at the podium, which is on the corner camera. Originally, we had these switched around. We had the corner camera. It could be here, but we found that it was, because it only sits 8 feet off the ground, that people could walk in front of it very easily or sit on the pews. So we switched it around, and the ASL camera is on the ASL interpreter, which seems to make sense. That seems to be what the design intent was. So using OBS, there's many scenes that they have to refocus the camera, and this is where the joystick operations becomes really handy, is in using OBS. It makes it a lot easier to do these things. So, and like I say, we have some other operations where we use this. So this right here you see is a snippet of the design plan that the consultant designed, and then it goes through and it was approved by Church Engineering. But there were some things when they put this together, and one of the guys that designed this, I used to work for years, and we used to install sound systems together in LDS churches, but he went on to be a design consultant. They didn't understand the concept. They had this idea of putting a laptop in, and there's this video to text that would kind of insert, but they didn't really understand that. And the other thing we didn't like is they wanted to use composite video on the camera here to send that back. But one of the things I want to point out here, it's really important, is that there were right here, they also installed 2 Cat5 cables, and the one cable is the one that we use right here, the CP2A. That's the one that's actually in the patch panel back in the stake workroom that we actually, you're going to see we actually do have that hooked up, but we have an idea what we can use this other Cat5 cable. We're going to kind of trace that down. They never installed this IR hub. I guess what that was for, so you could actually take the remote and point it right there, is what it's for, but it never really happened. So there were a couple of problems with the cameras. That one, they had on there to reuse the original coaxial cable there, and the original coaxial cable was CATV grade, and we were having all kinds of problems with the image going to black and white. Then all of a sudden they did a little research, and it didn't occur to me that the SDI, the serial digital interface, has frequencies that go a lot lower than what's used in CATV grade coaxial cable. Just has a copper clad, and the center conductor is still usually or whatever, because it actually rides on what we call the skin effect. It actually rides in there, but the camera information is actually goes much lower. I guess it must be lower to down into the audio level. I don't know exactly what the frequency is. That's something I probably should research and be able to say that definitively in a presentation like this. But anyway, we worked out a deal with General Communications, got that set up. The other problem that's still outstanding is that that center camera was having vibration problems, and to get it working, we got some memory foam and some rubber pads and put it under the camera. And if you go up there and look at it today, you'll see it's sitting kind of higher on it than the old one did. Still a discussion we need to have with the FM group. I bought a special camera mount, but it needs to be mounted to a metal pipe. I could schedule 42-inch metal pipe that we can run up into the attic and attach it to uh, the uh, the beams that go across. And I don't know if it's still a wood beam like you see in the chapel or if it's metal, but we need to try to isolate it from all of the equipment up there. That's stuff that still hasn't happened. If you look really close, you can still see the vibration when the HVAC stuff goes on. But we got most of the memory foam. So that's kind of an outstanding thing. Then the other thing here is that luckily, General Communications, when they were doing their takeoff, they ordered the wrong one. They didn't specify this. They ordered one instead. It was SDI to analog. They ordered one that was SDI to HDMI, which is what we need to be in the right place. So this is the redesign that we ended up doing. So we had the first HDMI dropout, and then we added a second one that went from. So the first HDMI goes out. It went down to this two-way splitter, and it goes into the ASL disc. We have one that goes as an input into JTech. It's an HDMI switch, and which is what we were using before this Extron was put in there additionally. I'm not going to go into that too much, but then we have another split that if you followed that down, if you could see the actual redesign document here, it goes directly into the ASL PC, and we're using an HDMI to USB adapter so we can get that's how the camera is put into OBS. So so there you see. Then we also have the ability to be able to bring the camera if we needed to the right on the clerk's desk. We had this virtual state conference. Part of President Stewart's idea was that we could have use a regular Zoom where you're toggling back and forth. And it actually worked well that way. So if we wanted to just be able to have a PC that's running Zoom and we just want to use that center camera, there's an opportunity. I'm not sure we're going to use that much, but that's a capability that we have. But there's that two-way splitter I just talked about. One going into this JTech and one going directly to the ASL PC. So the other thing that we had to get rid of it, I just couldn't try to get it to work. I tried to get the composite video. I don't know why. This is one place where I don't know why they wanted to do this. This is the old TV standard. I scrapped the video distribution amp that used to be there, and instead we put in this multi-com modulator. I found a modulator. It was about $250. I just donated it. And it's got an IP address so we can reset it remotely, and go in and change it. It was default at digital channel 2-2, and I thought it's great. We'll just leave it at that because I don't think we're going to have much interference inside the building. So far, we haven't seen it. We haven't tried to reinitialize. My idea is if the thing ever rebooted or anything, we'd have to worry about having any custom configuration, the default configuration work on here. So we just take the regular CATV grade coax, which is what they had in here, plugged into this 8-way splitter, and the TV's out here. That's another story I won't get into, but we just tuned those to 2.1 done, and then we also got the mother's room working. That wasn't working. That also had to have a converter, and that wasn't working well. So then on the rostrum we have some TVs, and we could they're either HDMI or we could tune them to 2-2. So there's actually 2 inputs on those rostrum TVs. That was something I wasn't planned on doing, but when they were doing the redesign, General Communications had a subcontract doing all our cabling, and I guess it was their opportunity to make a little more money, and they pulled some more cables. So this is my design that I put in here that's overlaid over the top of the actual official church design, showing some of the additional stuff that we've done there. But the other thing that we did, getting back to the camera, this is I've documented where we put in the RMIP10. One of the things that's wrong on here is I thought that we actually, it also showed a BRBKIP10, and it may be supplied. I'm gonna have to go back and check through some of the cabinets in the Steak Workroom. Maybe we still have this card, but we're actually using the default card. It's in there, and then there's a data switch here. There was one recommendation. This really could just be a closed network here, but we also use this data switch to pick up the church network from by extending it off the pulpit there, and we have this multi-com modulator actually plugs into it, and we also can have the laptop it can plug into it and get data network. So that's what this is what we did on the redesign to get that to work as far as the ASL capability we need to do. Okay, so we're going to go on and talk about how we set up the Sony camera as it is right now. So here you see is the takeoff of this is actually on the list of where all everything there you can see that we had the RPMK and the BRK IP10. So they had that specified. One camera controller, and they show this here, and that may be somewhere. We'll have to go see if we can find it. I'm not sure we'll use it though, because I'll discuss that a little later. Okay, so I under the assumption that we had the IP10 BRBK card in there, but Dustin said, "Oh no, you're nuts." He went up and took a picture of this the back of this up there on the, you can kind of see here's that memory foam that this is sitting on, the camera is sitting on, but this is from the back, from up in the mechanical room, and you can see here the lights of the chapel on the side here. So let's go through and look at this. So there's first the LAN connection that actually, luckily they already had this cable running down through the tunnel, and they had it running over to the clerk's desk, which was a good place for it. That was right where we actually needed it. So, and I think there's another cable in here that runs by it. We're going to go check to see if we can find that, because we want to think about using this other VISCA option on there. So there's the VISCA, that stands for Video System Camera Architecture. So then there's a place where you can select the ID. The ID would be so if we are able to switch from IP to using VISCA RS-232, then you have to have an ID for each one of the cameras. So if we were able to get the Lumens on this IP10, which we don't know if we can, we think we might possibly be able to do it if we switch over to serial. But that's one of the things we want to test in the future. But then we'd have to give them a system slot. I believe the IP10 would be 0. This would be 1, and then we'd assign a 2 to the Lumens camera if we were to get them all on the same controller. Okay, so this is showing the design. I don't know why it's doing that to me. So there you see the connections there again. We're showing you that. Now the IP addresses that are assigned here, we did that. I did those in the church, the TM manager, where you can assign static addresses. So these were actually just these addresses came up by just leaving them on DHCP. So when the camera turned on, it sent out a request that we have it in there to saying, oh, we put the MAC address in there to say this is the IP address we want it to be persistent on. So it's I guess what it really is it's a persistent DHCP address. But in our situation, we just call it it's basically static. So there's where the connections would be. That you can see the RS-232 is a DIN, and the RS-432 is a like a sense connector. But we're we want to eventually try to the controller we can either it has to either be totally over IP or it could be set up, flip the switch. It could be VISCA RS-232 or 422. RS-422 is a balanced, what we balance version. It means that it has a separate pair for the transmit and the receive, and that would go a long way. So I would think that's what you'd use, but surprisingly, RS-232 seems to work this as well. So there's the SDI out for the getting a video camera. There's that system select that I was talking about. We'll finish that up. This is the first page of the RM IP10 setup. It's a camera list. Table's condensed. It's a lot bigger than this, but since there's only one line. So this is where you would put in a MAC address of the camera. That's really important because they're basically just going to talk to each other. They could be a closed network, but we have it set up to be on there. So the RM IP10 setup is a thing you can download off the Sony, and you just web page, and you just run it. It's not really anything you install. You just launch the file, and it brings this up. Okay, so here you see the second tab with the controller, and you'll notice that you'll see in the message column there that the configuration is protected. So this is a screenshot we took afterwards, but if in the actual, and there you see the RPM setup tool at the very top, you'll see it shows the IP address. This is the ASL PC. That's also one that we have set up we set that up through the persistent DHCP. It's on the church, the IT, their tool, the TM. And you see the read only, but you flip a dip switch on the bottom of the IPM controller, and then it takes that protection off, so you can add to this. And then this is the third type, the camera table. If we had some cables, this basically makes the assignment where it is on the buttons that are on the control controller itself. And I haven't really gone over that too much. We'll probably do another video that shows how we actually operate it. But this is how that works, or how it's set up in there. You can see that's still the MAC address of the camera and its IP address. I took my laptop and went in and sniffed this. I have another little hub that I use that I just ran the VISCA. The IPM is sitting on that ASL desk, and there's an Ethernet cable that runs under the floor over to the clerk's desk, and I just inserted my sniffer in between so we can see how these two work to interact. And so you can see that the VISCA protocol, this is actually all UDP. You can look up the command. Sony's got a book. It can show you what all these are, but it's basically this is where it's kind of sitting idle, and then you can see the reply connection that's sent in there. It's kind of interesting to look at this in Wireshark. Okay, so here you see it changes a little bit. We have a few more commands when we're actually panning the joystick there. You see there's the reset command that resets it, and you'll see that we have an acknowledgement of the command sequence, and then there's the completion. So you see there is a command. And now the dissection that we found in Wireshark for this, someone wrote, it's not perfect. It doesn't tell us everything. If we probably could develop, we'd find it that command sequence, command unknown, would probably give us some real data. If we took time and looked through the Sony documentation, we could find out more about this. So there's the reply with the completion. Okay, so we'll talk about the Lumens the corner camera setup now. We really like the RM IP10, and we made an attempt to actually install tried to get it to work on the IP10. I won't go into all the details of how we tried to do this, but we found the big problem we have is you can't even enter it in the database. It seems to Sony seems to know that this is not um, this is not um, a good MAC address. Is what we configure. So what's interesting is that the Sony controller sends out an ARP request with the MAC address of the Sony camera. It doesn't care about anything else. It doesn't try to ARP to find that gateway or anything else. And so this sets up, and then they start talking. And there you see the message we got back, the hex rejection message. We tried to set it up. So there's none of that. Okay, so this is what we see at the end. If we could, it would be nice if we could just trade the Lumens in for another Sony camera put in there, but I don't think that's going to be happening. So, as I discussed earlier, there's those extra cables they ran in the 2019 upgrade that we're going to try and flip, and we're going to get some. They're about $30 a piece for a pair of 8-pin serial connectors, and we're going to try and see if we can make a switch. Probably do it sometime later in the summer 2022 to see if we can test it there. But for now, we have a separate Logitech joystick that we use for the Lumens camera. So we're going to go through the great work that Dustin Silfast did. He did all this, and I'm just trying to report what he had put together. He's very tenacious at trying to figure out stuff. I guess we're both anal, but we're just kind of different areas as we focus in. So there is, instead of actually trying to show you a photograph of what's actually on the rack, there's a lot of other cabling there. It was just cleaner to give you a takeoff off the, this is off the design plan that the consultant did, the church approved design plan. So whereas you see that camera controller there to the very right there. Let's see if I can get my little pen going there. You see the camera controller, and we're going to extend the USB cable. So instead of having to run a long USB cable over to where we had the Raspberry Pi in the satellite dish, the old satellite cabinet, we moved it over to the rack. We still got to try to put it in there permanently as in this video here, but the time that I did this video. But we're going to go to, but here he uses the IP address of the Raspberry Pi. The Raspberry Pi has a couple other functions it does for it. We use it also to control the Extron video switch that it was installed in the 2019 upgrade. I won't go too much of that. I've got another video on that that talks about how we use that. Then it's also a manual texting that we used during the state conference. And that's another video I've got on that. But this is the third thing that we got on here. We're going to basically take the serial data that comes off the RS-232 connection there, and then wrap around some IP headers, TCP, and have it available. We could pick it up off the network. So there you see the basic configuration, the way it's wired up. Let me see if we can get on to the next slide here. Okay, so this is basically what Dustin set up here. So the USB adapter, the Keyspan USA 19HS, is already automatically loads on the Raspberry Pi. I'm sure it's because there's no real serial port. They're probably native to it because you'd have to have a USB connector to be able to convert it. So the configuration for the device on there. This is the in Unix you have the device, and it's T2Y USB 0 is the line. So it uses the sudo dms command to be able to find that. So on the Raspberry Pi, it's just like if all Unix boxes, there's under the etc directory, usually an rc dot something, DDD or something like that. But here's an RC local, and that's usually a file where you want to put stuff you want to boot up on, execute on boot. So this is the whole line you put in there. So you know what, the regular cat or concatenation command, that's where you can create files and so on. So the socat command is socket, where you can create a socket. So we will literally want to create a socket, and here he's using socat. That's going to be TCP for IP4, and we're going to listen on port 5678. That is a standard port for VISCA PTZ camera over TCP. And we're going to make sure we're set at 9600 baud rate. We've not tried to see about changing. On the remote control, you can change it to 3480 or whatever it is. But that seems, the 9600 baud, it seems to be fast enough. As you're going to see in the display we have at the end, that we can do a lot of stuff. So, okay, so that's good there. So there's a complete line that you see, the whole thing all in one straight line. And there's a screenshot of the file that loads in the rc.local. There are some additional notes on the troubleshooting, and we got a screenshot here of how we actually use this in actual troubleshooting the process of seeing how things were working. There's an example of this troubleshooting to use with the socat command. This is trying to get everything set up and finally get this process working. Okay, so on the ASL PC, man, we sure use a lot of USB ports on the ASL PC. I think we have an extra little divider we have to have on there to share some of these. But there's a Logitech game controller, and then there's a PTZ optics installed. It's a freeware that set up to set this up. Okay, so here's the PC optics as you launch it, and this is what it looks like in the regular mode. And we're gonna go on to the next slide, and we'll see how we go on and do the setting. Okay, so this is already in an expanded mode. There's an advanced view on this. You can see some other stuff here to the side, but we're going to focus on here. Just we want to go to settings, and we're going to do menu select a multi-camera setting, and this is where we tell the software about the Raspberry Pi, its IP address there, 192.168.108.23, and that is where, and the Raspberry Pi is taking the serial data off the serial port, and then it's using that socat command to turn it into a TCP port. So we're basically wrapping IP headers around the basic commands that were coming off the serial port and sending it to the camera here. This software knows how to strip that off and use it. So that's the. So when that's done, we're going to go back to the settings again. We're going to go to additional input setting, and this is where we set up the joystick. Okay, so I'm going to decipher Dustin's notes here for this. Here is the Logitech controller. It was got 14 bucks to put in. According to this, we take and push that mode button there, and it lights green. And while we have that on, we can make some. We select the camera and of the PTZ optics, and there you can adjust. You can flip over to advanced view. We don't actually show that, but if you hit the view, there's advanced view, and it brings up this panel here. The original is just like this. This is just the basic view. Then the advanced view gives you all this extra stuff here. So that is the so we have controls left and right. So he talks about the left hat, pan and tilt. I assume that's what it's got to be there because that looks like equal to the pan and tilt that we have control that we see on the PTZ optics. And then there's the top right shoulder buttons for zooming in and out. And then you can do presets here for focus. And I assume that that means that we're going to each one of these presets that you would probably have, you would probably be changing the control speed options. And I see him doing it, and he's probably doing using the remote to probably help get to where he wants, and he gets that preset so he can just push those buttons and it'll get where he wants to get real quick. So then there's the mode button for focus. That seems to work best with autofocus instead of trying to do anything else. Let the program do it. Okay, so we're gonna do a little demo here, video I shot off my iPhone. We're looking at the monitor. It's on the side of the ASL PC desk. You'll see.
Go ahead and move it around.
You're gonna see how the joystick is actually pretty quick. We can do this with the remote. Just moving it this quick. So you can imagine. So this would be like the Saturday night.
How about going down? Right below the camera. How far can you get that way?
Where they'll have people talking. So and they can hand them a wireless mic out to the audience.
That's pretty good. Actually, I'm surprised you can go that closely with. Okay, can you zoom in on the other side? Right there, zoom in on the far. How far can you get to that door? That's right. Okay, that right there would be about where someone would be talking. If you gave them a microphone, it'd be right there. Back up just a little bit. Now go. Okay, so sometimes they'll be like in the middle of the pew, right there somewhere. Say, zoom in on the middle pews, right in the middle. Like they handed the microphone over. Yeah. Oh yeah. That's quick. So now can you preset the? You can't preset the pulpit, can you?
Yeah, I've got a pulpit preset.
Okay, so that's it right there. You get a preset and that goes right there. That's pretty quick.
I can get 3 presets on the controller.
Okay.
And everything else I have to click on the
Okay.
computer.
Well, I think the pulpit being preset is probably most important. You zoom out to look at someone talking, and then when President Stewart talks, you just hit the preset. Okay, so you're zooming.
Okay, so that's enough of that video. Let's see. We'll go show you a little bit of that. You can see how it operates with OBS here. So there you see OBS. He's manipulating. You see OBS here in the background, and there's 2 screens on the OBS. I got a whole video on OBS how that works, but the screen on the right, he can pre-queue up stuff on the left, and we flip it over to the right, and that's what shows up on the whole HDMI system in the building, in the stake center. So there you can see it using. He's actually looks like he's got the controller down in his lap.
Like you're going out the.
And you'll see him occasionally touching.
There we go. See someone that's got the wireless
software
mic right
controller.
there. There we go.
That is cool.
So that gives you kind of an
I
idea
think
what's-
you'll like it.
That is cool.
I think you'll like it.
And that's it. This is the end of our presentation. Hope it wasn't too long. Tried to cut this down. I'll have a PDF version of this that probably do one. It's only about 10 minutes long to do.